Hi everyone, good afternoon. These are going to be the last notes from the professor for this microbio class I'm taking. This is going to be about the foods made by lactic acid bacteria. Okay, so this is basically the end. We're also going to combine the sensory tasting notes into this one. So this is basically the end of the road here. What a journey it has been, really. Okay, so I sounded so sarcastic when I said that, but I truly mean this is the end of the journey here in this class. All right. Anywho, so the lactic acid bacteria will create these tart tasting qualities of yogurt, pickles, sharp cheeses, and some sausages. And then these are just like the genera: Lactobacillus, Lactococcus, Streptococcus, Leuconostoc, Pediococcus. All of these are going to be obligate fermenters, and they're going to also produce lactic acid as well as some other flavor active and aromatic compounds as the end product. Okay, first food will be yogurt. The microorganism will be a combination of 1-to-1 ratio of Streptococcus thermophilus as well as Lactobacillus debrucki bulgaricus. Bulgaricus is the subspecies. That's also where it's from, Bulgaria. Again, 1-to-1 ratio. The feedstock will be cow's milk, but you could use goat, buffalo, water buffalo, caribou. You could use skim or full fat milk. Either one is okay. You just need to make sure it starts at pH 6.5. You then heat it to 85 degrees Celsius so you prevent curds from forming. It denatures the proteins present in the milk so you don't get any curds. And then you're going to drop it to 40 degrees Celsius afterwards. So 85 degrees to 45 or 40 degrees Celsius later on. Fermentation will actually occur at this temperature, 40 degrees Celsius. The growth of the thermophilus, the Streptococcus thermophilus, will produce lactic acid, acetic acid, as well as acetaldehyde. The Lactobacillus debrucki bulgaricus will only be favored when the pH is less than 5.5, I should say. Less than 5.5 there. This species, the bulgaricus, will produce lactic acid and acetaldehyde. It doesn't make acetic. Now you're going to cool the fermentation broth once it releases at 4.3 pH, and then the time will be 2 to 3 hours. Recovery and processing, you could have some fruit jams at the bottom and some diacetyl as well, again the buttery flavor. Straining or centrifuging will increase the thickness of the yogurt, so that's how you get to Greek yogurt. You're straining it more to increase its thickness. Okay, let's go to cheese now. Cheese production, it's 22 million metric tons are made globally. Leading producers will be the US with 5.6 million metric tons. Other top producers include Germany, France, Italy, and the Netherlands. I guess you could guess which state here in the US makes the most cheese. Anyways, the cheese microbes are going to be the Streptococcus and Lactobacillus species, not Lactococcus, but Lactobacillus. Some of the species will be Cremoris, Casey, Helveticus, Bulgaricus for the Lactobacillus again, and Casey, that's also Lactobacillus actually. Let me just move some of these around. Okay, Cremoris and Lactus durans and Thermophilus from Streptococcus will be used. Alright, curdling. This is when the acidification or drop in pH will cause the milk proteins to kind of coagulate and form this top layer. You add acetic acid to accomplish it. This is seen in paneer cheese, which is an Indian style of cheese, as well as queso fresco. The lactic acid bacteria could also create this curdling effect too. Enzymes could also aid in this coagulation. You could use rennet from the calf's stomach, or this chymosin, which is produced by genetic engineering. Propionibacterium shermani is added to Swiss cheeses, and that's how you're going to get those holes, the pockets of the gases, as well as the propionic acid. Okay, so now curd processing. This is the next step. You're going to remove from the whey. You're going to remove the curd from the whey. In soft cheeses, this is the finished product in soft cheese. Curds of aged cheeses are, however, they're going to be milled, drained, and salted. The salt will remove moisture and preserve the curds. In some cheeses, the curds may be heated to force more whey for the curd. Now you're going to mold them into shapes. So the pressure is used to form the blocks will influence how hard the cheese will be. So if you add a lot of pressure by using the blocks, this will create a harder cheese. Okay, now let's talk about ripening the cheese. So the texture will improve from a rubbery consistency to a characteristic cheese feel. And the bacteria breakdown of the milk fat and the casein will cause these fats, amino acids, and amines to start forming. Casein is where you get Cas amino acids from. I remember from one of the previous videos we were talking about this research project in class, and then we mentioned Cas amino acids. This is where you get it from the milk fat, from the milk. Okay, so we also have some secondary microbes in ripening cheeses. We already talked about Propionibacterium shermani. The carbon dioxide will cause the holes in Swiss cheese. You also have these organisms living in low salt environments. The brie cheese will have a surface covered in the spores of penicillium, as well as yeast. And the proteolytic and lipolytic action will produce this nice, unique flavor to brie because of all these flavor compounds that the penicillium is creating. Blue cheese will actually use penicillium mold spores, and then you're going to inoculate the curds. So that's, again, another cheese that involves the penicillium. The penicillium will produce these fatty acids and methyl ketones during the ripening. All right, let's talk about fermented meats now. Most of these will be sausages, such as bologna, salami, pepperoni, and then also summer sausages. There's going to be a lot of salt, so if you're ever going to have any type of sausage, make sure you wash it down with a lot of salt. No, don't do that. Drink a lot of water. There's going to be a lot of salt already on the sausage. Don't add salt to it. Drink water. Okay, salt, sodium nitrate, as well as lactobacillus species will be present in the ground meat. You're going to mix them together. The pH will drop to 4.2. You want it to drop to as acidic as possible to 4.2 or less, because that's going to kill any of these other microbes that might be bad for you. The meat is then placed in casing, and the sausage will spend 20 days in a drying room to reduce the moisture. Sometimes you could add penicillium on the outside to make this like edible mold texture on the outside, give it more flavor as well. All right, fermented vegetables. This usually involves pickling. So this method originated as a way to preserve the vegetables for later. You have sauerkraut, which is cabbage. Pickles, of course, are cucumbers. Olives are also pickled if these are the fancy olives that are grown specifically for their flavor, so you could pickle those. The fermentation is usually done by the lactic acid bacteria that's already on the vegetables. So you don't add like a pure culture or anything like that. Let's look at sauerkraut. This is cabbage that is shredded and layered in 2% salt, and then it's packed to make this anaerobic environment, so you kind of vacuum seal it. The salt will draw out the water and the nutrients from the cabbage, and it also creates this brine to inhibit any of these bad microbes. The natural successions of bacteria grow to lower pH, so these are going to be acidophile bacteria. Leuconostoc mesenteroides, that's listed at the bottom there. Lactobacillus brevis and Lactobacillus plantarum. These are going to be the sauerkraut Lactobacillus and Leuconostoc species. Kimchi is the Korean dish. It's similar to sauerkraut, adds a lot of spiciness to it. The next food or product, I should say, is cocoa from the cacao tree. And just the fermentation, this is what we're concerned with. The beans are removed from the pod, either stored in a heap and covered in banana leaves, or they could be boxed. In 5 days, this natural fermentation will be complete. You introduce the microbes via the pod surface, the hands, or the knife. So these are the natural sources of the microbes. You're not adding a pure culture in. The fermentation allows complex chemical changes to happen with the cocoa beans. So we have oxidation, the breakdown of proteins into amino acids, and then some color developing as well as flavor developing reactions. The longer you ferment these, the darker the brown they will become. So the steps in the actual process of fermentation of the cacao pods and the cacao tree. So first you'll have the lactic acid bacteria. These are going to break down the sugars to produce lactic acid. Next, you're going to have yeast to break down the sugars to form ethanol. Step 2. Then you're going to have acetic acid bacteria to break down ethanol into acetic acid. And then step 4, the bacillus species are going to just break down any pectins that are present. Alrighty, let's go into the sensory development lab, or testing the products. Okay. This one I am going to be writing out. As we're going through, because there's just a few slides here. Let me find them. Oh wait, this is from not last semester, but let me get to the newer one. Sorry about that. There's going to be just some empty space. All right, sensory lab part 2. Okay, descriptive analysis. This is going to be used to train panelists to objectively ID and measure sensory qualities of products. I'm going to highlight everything later. So you're going to have this established lexicon for the product. You're going to be using these flavor wheels. Then a scaling system to measure intensity will be created. And then you're going to also need extensive and ongoing training for descriptive analysis as well. First part, lexicon development. This is where you're going to establish a list of attributes. You're going to define them, and then you're going to have these flavor references in order to kind of demonstrate the attributes. Alrighty. So now the next slide will be the triangle test. Okay, so in sensory testing, the triangle test, would involve 3 samples. 2 are the same. And of course, the taster is not informed as to identity of any of the samples, and then which is the odd one out is the question that's asked of the tasters. Which is sweeter, which is more sour, etc. Next type of test in sensory analyses of a product would be paired comparison. This is where the taster is presented to 2 samples. Are the samples different, and which is sweeter again? It's just basically A or B. We have the duo trio. The duo trio test is, again, 3 samples. However, one of them is designated as an open sample or an open reference. And now, you have to decide which other sample is the same / different. So it's kind of like the triangle test, except on the duo trio you're given the identity of one of the options, basically. Okay, ranking. This is kind of self-explanatory. You just rank the various characteristics as order of preference or intensity. There's also the threshold test. This is where the sensitivity testing is used to establish the threshold of the taster's ability. And the ability being tested would be the detection of specific flavors. Okay, a series of triangles are presented with decreasing levels of the attribute. And then the threshold is the last continuous correct answer. This could also be used to determine the threshold level in a beer where it affects flavor. Okay, I think there might be a few more things here. We have profile attribute analysis. Or PAA. PAA is developed by Using what's this? Arthur, no, that's just the name of the person who found it. The flavor profile method. When using the PAA method, samples are randomized for blind evaluation. The taster is provided with a list of attributes with intensity scales. These are usually 1 to 7. We also have quantitative descriptive analysis, which is QDA. This is going to be similar to PAA. The taste panel will rate the attributes on a structured or unstructured scale. And then, for example, the test may be performed using a form to compare other brands to Budweiser. So it's just brand comparison. Trueness to type test is another variant of these. This is a grading test to classify a product on the basis of several attributes. So 7-point scale. At a 3 is the just right. Should say 3 equals. There we go. Too much or too little. Would be 2, 1, or 0. And then you have space for abnormal notes. So this requires tasters that are trained on the product, so a minimum of 5. Okay, panelist selection is one of the last parts here. You write that better. Basically, good health and hygiene, good attitude, no cologne or perfume or smoke, you don't want to eat anything strongly flavored 30 to 60 minutes before tasting. And the sensory taste room, I think, is the last thing. Yep. Okay, sensory taste room. The sensory taste room, they're going to have a comfortable temperature. You're also going to have proper lighting, odor-free, and to limit the amount of distractions, it would be a quiet place. Right, those are all the notes from the foods made by lactic acid bacteria, and then sensory testing. And that concludes all the notes from the professor for applied microbiology. Thank you so much for tuning in. Do something nice for someone. Be safe out there, and best of luck.